In this video, we are going to look at the second part of our homework. So the second part is asking to calculate the standard deviation and mean for the height variable. So that's the first question. So here is my data set, and one of the variables that I have is height. So the first question or first part A, is asking to calculate the mean, the average of weight, and also the standard deviation of weight. So you can do this in either Excel or SPSS easily. So I have imported this data set to my SPSS. So in order to calculate the standard deviation and mean or average for a weight, so I go to the analyze descriptive statistics, and then I click on descriptives. So I can import height to my variables because I'm interested to calculate the standard deviation and mean for the variable. So my variable is height, options. So under the options, I can select the standard deviation and mean. So that's the only two parameters that I'm interested. So if you're interested on other parameters, so you can check. So but as the question specify, so we are looking for the average or mean and standard deviation of height. So I check standard deviation, mean, continue, okay. So here it is. The average or mean of weight is 118.97 centimeter, and the standard deviation is 5.463 centimeter. So that's the answer to the part A. The second part is asking to calculate the probability of particular value of height. So we can calculate the probability of particular value. So for example, let's say the question is something like this. So we know that x represents the height. Okay, so the x represents the height and is following a normal distribution. So this symbol represents my random variable x, which represents the height, is following a normal distribution. N stands for normal, with the two parameters. So the average is the average was 118.97, 118.97, and the standard deviation is standard deviation was 5.463. Okay, so now the question, let's say the question is, what is the probability that someone's height is less than 120, right? So we want to answer this question. So what is the probability? P stands for probability. What is the probability that someone's height is less than 120? So if you guys remember from the previous lecture or previous videos that we discussed, we need to convert normal distribution to a standard normal distribution. So in fact, we need to convert x to z. The formula is equal, the formula that we are going to use is z is equals to x minus mu over sigma. So this is how we can standardize our normal data. So instead of x, I'm going to write z, because x minus mu over sigma is z, right? So the probability that z is less than, so that is my x value, 120 minus 118.97 divided by sigma. Sigma value is 5.463. So if I want to do the calculation in Excel, so let me open a new sheet. So if I want to do this calculation in Excel, so I can say 120 minus 118.97 over 5.6463. So that is my Z value. So I am looking for PZ less than 0.1185. So I need to figure out the probability, right? The probability that a standard normal data is less than 0.1885. So we saw that in order to calculate this probability, I can say norms dist. So norms dist stands for normal standard distribution. It has only one parameter, z. My z is 0.1885, 0.1885. So the probability is 0.57, 0.57, or I can say 50% chance. So there is 57% chance that someone height is less than 120, right? So this is this column represent the heights, right? So these columns represent the height. The first individual has a height of 127. The second individual has a height of 118. So now the question is, if I pick someone randomly, what is the chance that his or her height is less than 120? So the chance or the probability is 57%. There is 57% chance that someone height is less than 120 centimeter. Okay, so this is how you can make an interpretation. So now let's go back to this question. If this question says that we want to calculate the probability for all these numbers, right? So what's the probability that someone has a height less than 127? What is the probability that someone has a height less than 118? What is the probability that someone has a height less than 108, and so on, right? So we can do this using compute variable. So I go to the SPSS, and so there's options here which under transform there's options called compute variable. So transform compute variable. Okay, so I go to the CDF. CDF stands for cumulative density function, and non-central CDF. So we assume that the height is following a normal distribution. So like I mentioned earlier in a previous lecture, we discussed about the normal distribution. We say that one of the statements that we made was the popularity of normal distribution. So if you have enough sample size, generally speaking, if your sample size is greater than 30, you can use normal distribution if you have no information about the distribution of your variable. So here our sample size is 100. We have 100 observation or 100 people. So we have measured the weight of 100 people. So even if we don't really know the distribution of weight, we can assume that the weight is following normal distribution because we have enough sample size. Our sample size is 100, greater than 30, so we can go for normal distribution. So that's why I'm going to look for normal distributions. So I'm going to click on CDF.normal. So we have three parameters. The first input argument represents the x value, right? So we are looking for those people whose weight, whose height is less than a specific number. So what is the probability that x is less than 120? What is the probability that x is less than 109? So my first input argument is height, and the second input argument is the mean or standard deviation. So we calculated the mean and standard deviation. So we know that the mean is the mean or average of height is 118.97. So 118.97, and oops, that's a typo. So, and the last input argument is standard deviation. Okay, so we have calculated the standard deviation in previous question. You see that here we calculate the standard deviation. So the standard deviation is 5.463, 5.463. Okay, so comma, so 118.97, 118.97, 5.463. Okay, so now I want to generate a new variable, and that new variable will show me the corresponding probability for each number. So for example, what is the probability what is the probability? What is the probability that someone's height is less than 120, right? So I will have a new columns called probability, or whatever you want to call it. So we calculate this probability, right? I just show you how we can do a calculation, right? So this is the calculation. So, and then we will have calculation for probability that x is less than 118, right? So so the first one is 127. The second row represents the probability that someone's height is 100 less than 118, and so on, right? So we have a probability associated with each x value. So that's why we need to generate a new columns. I'm going to call it probability. Okay, so you can call it anything that you want. So hit OK, and here it is. Okay, so actually this is 120, so that's my bad. So 120. Okay, so what is the probability that x is less than 120? So the answer is 0.7, right? So let's look at here in SPSS the probability that someone height is less than 120 is 0.57. So in other words, there is 57% chance that someone's height is less than 120. So we have already answered this question here, right? So the probability that someone's height is less than 120, the probability is 57%, right? There's a 57% chance that someone's height is less than 120. So and so we have done all this calculation. So the probability that someone's height is less than 109 is 0.003. The probability that someone's height is less than 121 centimeter is 64%. So the probability that someone's height is 119 is 0.5 or 50%, or there is 50% chance that someone's height is less than 119 centimeter. So this is how you can make a calculation. So you can do the calculation of the probability. So this is the answer to the second part. And now, what is the probability of being at most 114 centimeter, right? What is this asking? So at most, that means the maximum height is 114. So how we can mathematically represent? I can say, what is the probability the x is less than 114? Remember, x represent height. So x is a random variable representing the height of an individual. So what is the probability that at most? So less than means at most, right? So x, so less than or equal. So the x value or the height of people cannot exceed 114, right? Great. But if I say at least, right? So what is the probability that someone height is at least 114? So that means the height of that person could be 114, 115, 116, right? The minimum number should be 114. So here, when I'm saying at most 114, that means the maximum number of the height, the maximum value for height should be 114. So it could be less than 114, right? So this is exactly what this question is asking. So this is easy. So the question is asking what is the probability that someone's height is 114. So again, so we're going to I'm going to convert x to z normal data to a standard normal data. So what's the formula? Z is equals to x minus mu over sigma, right? So both sides of inequality, x, so I'm going to subtract mu from x divided by sigma. So what is this? So this called z. So that's why I'm gonna, instead of x, I'm gonna write z. So I need to do the same operation on the right hand side of my equality. So this is my x value, right? My x value is 114. My mu, so we have calculated mu previously. It was 118 point something, 118.97. 97, and sigma standard deviation is 5.463. So if you do the calculation and then you use normal standard distribution, the z value, so whatever the z value is here goes to here. So this is how you can calculate the probability using Excel. All right. So now in SPSS, so I really don't need to have this probability, so I'm going to delete the probability. So let's say the question is asking what is the probability that at most 114, how about 120? So I'm going to generate a column, call it 114, 114 and 120. So I can call these any variable that you want. So I'm going to call it x. Okay, so now I can go to the transform, compute variables. So here, instead of height, so I'm gonna insert x value, right? So x, so I'm trying to calculate the probability associated with these two values. What is the probability that someone's height is less than 114? What is the probability that someone's height is less than 120? Okay, so you, like I mentioned, you can do it in Excel using this method, or you can do it in SPSS using this method. Okay, this is using this expression. Okay, so if you hit OK, so you can find the probability, right? So the probability that someone height is less than 114 centimeter is 18% chance, and there is 57% chance that someone's height is less than 120. So this is how you can calculate the probability in Excel and also in SPSS. So you can make an interpretation. So which heights correspond to the probability of 0.6 and 0.35, right? So now the question in this part is the opposite of the first part. So in this case, the probability is given, but the question is asking for x. Okay, so now let's see how we can mathematically represent this question. Again, so I'm reading this question. So which height corresponds to probability of at most 0.6 and 0.35? So so the x value is unknown, but what we know is the probability 6, and which x value gives us the probability of 0.35. So this is what this question is asking. So we know the probability that is 0.6, but which height value gives me probability of 0.6? So imagine x represent the height is my following normal distributions, x representing height following normal distributions, right? So let's say the x value is here, so I really don't know which x value is. That's x value is unknown, but I know that this area px less than something that I really don't know, the area under the curve gives me 0.6, right? There's a 60 percentage in on this area and 40 percentage on the other area. So I'm looking for x value. So this is called inverse. So that's the opposite of the previous question that we solved it. Okay, so I'm gonna remove probability. So I'm gonna delete these two because we really don't need. Okay, so what we need to do in this case, we are going to add our probability in these questions. So we have two probability. The first probability is 0.6, the second probability is 0.35. So I'm gonna put 0.6 here, 0.35 here. So, and then I'm gonna call this variables probability. Okay, so, and of course this is scale, numerical variable. So I know the probability, but I'm trying to find the height associated with this probability, right? So I'm going click on transform, compute variables. So now I'm going to use inverse function. So when the probability is given, but the x value is not given, x value is unknown, so you need to use the inverse density function, right? So inverse density function, df stands for density function. So I'm looking for normal IDF, inverse density function, normal. So the first one is the probability, and the second one is average. So if I'm not wrong, the average was 1.8.97. Let's double check. The average was 118.97, and the standard deviation is 5.463. So 5.463. So then you hit OK. Okay, so one thing, so you need to define, because we are generating new variable, we need to assign a name. So I'm gonna call the new column x value. So the x value apparently we have done something wrong because the number does not make sense. Okay, so here's the problem. So I use log normal. Okay, so that's, so you need to make sure you use correct one. So normal, so these are, I didn't pay attention to the L, so you have to select the normal. Okay, so normal, oops, let me normal, click on normal. So probability is my first value, the second value is mean, which is 118.97, and standard deviation was, I forgot the standard deviation, 5.463, and then hit OK. So I'm going to use x value, that's fine. So here it is. So the probability, if I want to write down here, so now look at these four numbers. So I can say that the probability of x less than 120.35 is 0.6. So there is 60% chance that someone's height is less than 120.35 centimeter. So now let's look at these two numbers. The probability that x is less than 116.86 is 0.35. So there is 35% chance that someone's height is less than 116.86 centimeters. So this is how you can make a interpretation. So remember, in this question, the x or height value is not given, the probability is given. In previous question, in this question, the height or x value is given, and what you need to calculate is probability. All right, so now let's look at this question. Why it is not surprising to see probability of 130 centimeter is 0.95. So if I go back to here, so when we are saying the probability of 130 centimeter is 0.95, if I assume that x represents the height, and this is my normal distributions, so the average mu was 118, so 130 is this area. So this area, the area under the curve, represents 95% of my data. So it's less than 130, right? So in other words, 95% of height falls below 130 centimeter. Okay. So why this probability is not surprising? In order to have a really good understanding, so I suggest you to go to the analyze descriptive statistics, and you go to the descriptives, and you check the mean, average, the minimum, maximum, and probably, so these three numbers, right? So in order to answer this question, so it's better you look at the average value of weight, the minimum, the average of height, the minimum height, and the maximum height, right? So I have selected these three, continue, okay. So now let's look at these numbers. So I know that the minimum height is 106, the maximum height is 133, and the average height is 118. So if you look at here, the maximum height is 133, right? So, and most of the numbers, so you see that the most of numbers are less than 130 centimeter, right? 130 is very close to maximum number. The maximum weight is 133. So if I ask you what is the probability, so I know that the maximum weight is 133, so the probability that x is less than 130, right? So then, so I should give a big number, because 130 is close to 133, right? So all the numbers falls below 130, because 130 is the biggest numbers that I have in my column, my height column, right? So every single number is less than 133. So what is the probability that someone's height is less than 130? So that should be a big number, right? That should be a big probability. So 95. So that's why I'm not really surprising. So you can discuss about a similar answer. 108. 108 is close to the minimum, right? 108 is close to the minimum. So that means every other numbers are bigger than the minimum, or those numbers who are close to the minimum. So that's why I'm not really surprised that this probability is small. So now let's move on So the next question is create a Venn diagram. Of course, this is easy. Let's say this is our Venn diagram. So we have event A, we have event B. So I'm going to calculate the probability that event A or B occurs. This is equals to probability that event A occurs plus probability that event B occurs minus the probability that event A occurs and event B occurs. These two events occurs at the same time simultaneously. Or means either A or B occurs, right? So that means these areas, right? So A means this area, right? B means this area. A means this area and B means this area. Oops. B means this area, right? And as you can see, this area has been shaded twice, right? So because this is the intersection between A and B, so that's why we are subtracting probability of A and B. So this area, you see that this is the joint area. So this area, let me show it with the yellow. So this is event A, this is event B. So the yellow area belongs to the A and also belongs to the B. So that's the intersection between A and B. So this is the Venn diagram. So the probability that either A or B happens. So we're going to use this formula. And now let's answer this question using your depiction of the additional rules. Determine the probability of being at most 111 centimeter or 10 centimeter tall, at least 111 or 100 centimeters. So now let's look at here is the question. So we have two events. So the event A is when the person's height is at most 112 centimeter tall. So that means the height is less than or equal 112 centimeter, right? At most, right? The maximum height could be 112, but it should be less than 112. It cannot exceed 112. So it could be 112, it could be 111, 110, 109, all the way to 0. Of course, 0, some people have some height, right? So 0 is impossible practically, but theoretically it could be 0. So event B is an event that a person has exactly 110 centimeter tall. See, look at here. So we have two events. So what is the probability of being at most 111, 112, or exactly 110 centimeter? So what is the probability that at most 111 or exactly 110, right? So PA given PA or B. So PA or B is equals to PA plus PB minus PA and B, right? So PA means that the probability that the height is less than or equal 112 plus probability of B, the probability that the weight is exactly 110 minus the probability and that the height is at the most 112 and the probability is 110 centimeter, right? So now let's look at this statement. The probability that at most 112 and 110. So what is the at most? At most means so the maximum height could be 112, or it could be less than 112, right? So the maximum value of height could be 112 or less than. It could be 111, 110, any number less than 112, 109, 108, all the way to 0, right? So now we need to take the intersection between this statement and this statement. So less than at most 112. At most 112 means that any number less than 112. So that's the first expression. The second expression says that the height should be exactly 112, 110. So the 110 is this value. So the intersection between this statement and this statement means what? Means that we are looking for exactly 110 centimeter. So that's why I'm going to replace this statement with this one. The probability that at most 112, which means that any height less than 112 is fine, and exactly 110 centimeter means what? The probability that height is exactly 110 centimeter. So now let's look at normal distributions. So my x variable represent the height. Okay, so that is the normal distribution representing my variable height. So I'm looking for the probability of a specific value. What is the probability that someone heights? What is the probability that x is equals to 110? So in normal distribution, the probability of single points is 0, right? So we have always px less than 110, right? So because a single point does not give me an area. So when I'm saying that px less than 110, so I'm looking for this area, right? So the area under the curve gives me the probability. So when I'm saying what is the probability of x equals to 110, I do not get any area. So since there is no area, the probability is 0. So that's why here I have the probability 110 centimeter, which represent the probability of B. So this is 0. The probability of 10 is 0. So all I need to calculate is the probability of x less than 112, right? So the probability of x less than 112. So you can do it in SPSS, right? So the x value is given. So you are trying to calculate the probability. So you can use CDF function dot normal, right? So the first value is 112. The second value is 118.97. The third value is standard deviation, 5.643. So if you do in SPSS, so you can get the answer. Or if you want to do it in Excel, so you need to convert x to the z. So x would be z, probability of z less than. So the formula is z is equals to x minus mu over sigma. My x value is 112 minus mu. Mu is 118.97 over sigma 5.643. If I'm not wrong about this standard deviation. So whatever you get here, so you are going to use norm as this. So this is your z value, right? So then you get the probability. So this is how you can answer to this question. So this is the answer to this part. What does it mean when two events are mutually exclusive? Two events are called mutually exclusive if those events could not happen at the same times. Okay, so let's say you get to a traffic stop. Okay, so you get to the traffic stop. So let's say you have two choice. You have to either turn to the right or turn to the left. So can you turn to the right and left at the same time? No, right? Event A is turning to the right, event B is turning to the left. Turning right and left could not happen at the same time. So you should choose either turning to the right or left. So turning right or turning to the left at the intersection, at the traffic stop intersection, is kind of two mutually exclusive uh, events. So those events are called mutually exclusive if there is no intersection between those two events. If those events does not have any joint elements, in other words, if those events could not happen at the same time. So now let's say you are sitting in Phoenix, Arizona right now in March 15 of 2025 at a specific time, 4 p.m. You are sitting in your house in Phoenix, Arizona. You can be only in Phoenix, Arizona. So you cannot be at the same time in Orlando, Florida, right? So you can be on one place. So two mutually exclusive events are those events that could not happen at the same time, or there is no any joint elements between them. So using insurance status, what is the probability of carrying private insurance while on Medicaid? So this question is asking, what is the chance that someone has private and at the same time he has Medicaid insurance? So now what is this question is asking? If I want to mathematically represent this question, so this question is asking what's the probability that someone has a Medicaid, right? And so this and or, so we have two logical operators, and or. So what is the probability that someone is on Medicaid and uh, private insurance, right? So the answer is 0. Why? Because we have two events. Event A, if someone is on Medicaid insurance. Event B, if someone is on private insurance. So these two events are mutually exclusive, right? So why? Because these two events could not happen at the same time. So you cannot be on Medicaid and private insurance at the same time. You can be on Medicaid, let's say 5 years ago, and right now you can be on private, but not at the same time, not simultaneously. Simultaneously, you cannot have two insurance. You cannot be on Medicaid and private. So, especially in USA, is a crime. So now, how we can answer or how we can find uh, so this probability in Excel. So now I can use count if statement. So I need to look at two conditions. Okay, so I'm going to look at those people who have Medicaid and private. So the first time I'm going to select the insurance, I'm going to select the insurance range, and then I'm going to look at those people who are on Medicaid. So make sure you don't have any misspell. Medicaid apparently is correct. Okay, so and this second time I'm going to again looking at this range of insurance, and then these times I'm going to look at the private. Okay, so how many people? 0. So because every people or every rows, because every row represents the individual, every row or every individuals should be either on Medicaid or private or uninsured. So you cannot have two status at the same time. So 0 people, right? So in fact, So the answer to this question is 0, because being on Medicaid and having private insurance at the same time is not going to happen, because these two events are mutually exclusive, because these two events is not going to happen at the same time. So that's why the probability of being on Medicaid and having private insurance is 0. So this is exactly, we are, in order to answer this question, we are using the concept of mutually exclusive events. All right, so let me know if you have any question, so you can do the similar calculation for the other data set. And so I try to cover all questions. So again, so you can explain the interpretation in your own language. And if you need any help, let me know. Thank you.